Hello and welcome back to another video. In this problem, we're told that Jason leaves Detroit at 2 p.m. and drives at a constant speed along I-94. He passes Ann Arbor 40 miles from Detroit at 2:50 p.m. In part A, we're asked to express the distance traveled as in terms of the time elapsed. So we're going to create some points here that are going to be fitted by a function. So we are going to have points that are time elapsed, comma, distance traveled, right? These are going to be our x and y values. So he leaves Detroit at 2 p.m., so therefore at 0 time elapsed, he's traveled 0 miles. And at 2:50 p.m., 50 minutes have elapsed, and he's traveled 40 miles. So we have these 2 points, so we can now create a function that expresses the distance in terms of the time elapsed. So the slope of this function is going to be the change in y, 40 minus 0, over the change in x, 50 minus 0. This is equal to 40 divided by 50, or 4/5. This fits y equals mx plus b, equation of a line, y equals 4/5 x plus b. B is the y-intercept, which we know is 0, 0. So we can just say plus 0, don't even have to write it though. This is our function, y equals 4/5 x, where y equals miles traveled, and x equals minutes passed. B, we're asked to draw the graph of the equation in part A. We are graphing y over x. And notice that I'm only using the first quadrant, right? These things can't be negative. Time can't be negative. Distance can't be negative. 1, 2, 3, 4, 5. Marking every 10. We go from 0, 0 to 50, 40. And this is our equation expressed in a graph right there. Finally, we're asked what is the slope of this line and what does it represent? Well, we just found that the slope is 4/5. We used it to create our function. What does it represent? It's the rate of change of y over x. So it's the miles traveled y per minute x. This is the slope of this graph, which is representing this function, Jason's movement from Detroit to Ann Arbor.